Okay, welcome back to my world here, and here's what we've been given, and here's how the ball was kicked. It was kicked at a 40-degree angle at 22 meters per second. Hey, I bet you we could go to that little video tracker thing, this thing, and if we neglect air resistance, make an initial speed of 22, make it a football, and angle of 40 degrees. And if we measure it from this point, from where it was actually uh, I think we'd lose a little bit. I think we're going to get a pretty good, oh, 40 degrees. I think we're going to get a pretty good, whoa! Come back, Shane. Oh, the range, it went 50 meters. It went 50 meters. Am I sure that's okay? I mean, let's try 17. Sorry. I wanted to see. So we should get, yeah, okay. So it said it went 50 meters. So let's go back to 22 meters per second that it was fired. There it goes. All right, wow. Okay, so this thing went 50 meters. That's, if you think about it, that's a long ways. 50 meters. All right. I about said something stupid there, but I didn't. I caught myself. All right, at an angle of 40 degrees. So we've got to get our Vx and our v naught y. That's the first thing we've got to get, our initial velocity in the x. Now, last time we had an initial velocity in the y direction was 0, but this time, since we're starting this, notice the vector here, up and down. So v naught y would be 40 times the sine, 22 meters per second, times the sine of 40 degrees, and that's 14.14. I keep 4 sig figs whenever I'm doing these things. V naught x then is, I'm sorry, I should write this down for you. V naught y is equal to V naught times the sine of 40. V naught x is equal to V naught times the cosine of 40. Okay, there we go. Now, so this would be 22 cosine of 40 equals 16.85. Now, acceleration in the x direction, 0. Acceleration in the y direction, negative 9.8 meters per second squared. All right, now we've got to find the maximum height and the maximum range. All right, so let's figure out what the max height is. What's going to be, I got a question for you. What is going to be the velocity in the y direction, at the maximum height? So here it's going like this. Velocity at the maximum height in the y direction. V naught y is equal to 0. Or Vy at this point is equal to 0. V naught x is still 16.85 meters per second. That doesn't change, but that goes to 0. Aha! So we have an initial velocity and a final velocity. We can find the time. Time to max height. That's not the total flight time, but time to max height. So we'll just call this time to the maximum height is V naught final y max is what I'm going to call this, so we don't get confused with the final velocity when it's at the end. The final velocity in the y direction, the overall final velocity in the y direction, the final y is equal to negative 14.14 meters per second. That'll come in handy. All right. So we got 0. So we're going to have 0 is equal to V naught y minus GT. Aha! So 9.8 times T is equal to 14.14. And so T to the max height, T max, is equal to 14.14 divided by 9.8, 1.44 seconds. Now, I'm wondering what the total time is that it's in the air. What would be the time total? That's right. Total time in the air is T max times 2. Mother Nature loves symmetry. Took 1.44 seconds to get here. It's going to take another 1.44 seconds to get down here. 2.88 seconds. All right, but we still need the maximum height. Hey, we found the range though. Hate to jump around like that, but look, we got the range, which is equal to V naught x times the total time. So we've got 16.85 times 2.88. Oh, whoops. 48.85. Okay, so our one thing said 50 meters, so it's not exact. You know, you got to play with it from where it actually shot, but we got 48.58 meters. All right, still haven't found the maximum height, but hey, the maximum height's easy because look, I know I could do a quadratic because I've got y max is equal to v naught is equal to 0, where it started, because my initial height was 0, plus v naught y times t8, t max height, minus 1/2 g t max squared. Piece of cake. So y max is equal to 14.14 times 1.44 minus 0.5 times 9.8. There's my 1/2 g times 1.44 squared. 10.2 meters. There we go. We found all kinds of stuff on that one. All right. I'm going to quit here, and I've got one more little thing I wanted to show you that might be kind of fun to do. And it's using the real ESPN home run tracker and looking at home runs in major leagues.